Alright, so folks, this module 13 is going to be quite interesting. We're going to talk about these analytic functions. Okay. These functions work different than everything we have learned so far. Okay. Collectively, they're called windowing function. Okay. So let's begin by reviewing some of the functions we have done. We have talked about scalar functions. We talked about aggregate functions, which takes a bunch of records and just compute the results. Right? It's very set based. Here's a set of data. Go ahead and calculate the results. Now, SQL windowing works a little different. It works on top of results that's already produced, rather than a set of inputs. Okay, so the windowing allows you to specify the order as part of a calculation. So this all sounds very abstract. Okay, now this may look like an aggregate function. This is somewhat different. Okay, this function is called a windowing function. Why? Because it has the keyword over. It's not just a sum, but it's a sum over some things. Now, to understand how this works, we really need to run at least a couple of queries so you can see what the result looks like, and then these windowing functions will begin to make sense. Alright, the purpose of these functions is to help you analyze data on the row level against a group of results. That's not part of the group by expressions. So, still abstract, no worries. No worries. We'll clarify that in a jiffy. So here, in the demo code, we're going to create a view. The reason we want to create a view is we don't want to make it more complicated than it is. Okay. T-SQL. So we're going to set a bunch of views. Why? Because we don't want to be bogged down over how the query produced a result. We simply want some views that already works and give us good informations. Okay, actually no, I don't even type this select statement. So I'm going to comment this out. And comment it out. So this is what the view contains. Each category ID, okay, their product name and unit price. Piece of cake. Now, if I order by unit price in descending order, now I can see the unit price, no problem. Now that is number 1 expensive product, that's number 2 expensive product, that's number 3 expensive product. What if you want to create a column? Okay, what if you want to create a column that includes the rank? So that's how it works. You use the rank. Now that is a window function. That's not a scalar, not an aggregate. But a window function. A window function. Now window function. Now in this window function, it assigns rank in the following order. unit price in descending order. So this third column, sorry, this fifth column that we're adding, so this fifth column that we're adding will be tacked on, okay, to that row based on the window covering the whole table. Okay, so rank over the entire table. Okay, now you don't. I'm using an order by unit price just as a way so you can see the rank in sorted order. So notice you have 2, 43, 90. That's why 12 is missing, and you go straight to 13. Now, if you rather see 12, you can say dense rank. So in that case, notice 11 shows up twice, and we're not skipping 12, and that's 12 right there. Okay. Fantastic. All right, so that is to rank over the entire population. Now, again, it has nothing to do with order by, folks. The order by is specified already as part of the windowing function. You can order by other things. Cat ID if you want. Notice cat ID 1 beverage Qdomo. That's at least easy to read. Qdomo is number 1, right? Okay, so let's do that. You'll find Qdomo is still number 1, although it's no longer sorted in the price. Okay, rank. So we're not sorted by category ID. So all the beverages, this is in the order of the most expensive to the cheapest product. Okay, so what if you want to assign a rank? Let's say you walk into a school and there's classrooms, right? You go to classroom 1, classroom 2, classroom 3, and say I want to rank the kids based on their height. Okay, let's say I want to rank them based on their height. So all right. Fantastic. All right. So when you go into the class, you will say, hey, give me a rank based on each classroom. So every classroom has a number 1, right? The tallest kid. Okay. So that's why you can say add a partitioned by cat ID. So that means every category ID is now their own little classroom. Okay. Partitioned by cat ID. What's wrong with you? Partitioned by, not partitioned by. Okay, so you notice now we have the rank. So here the window where we're doing the order by is now based on the partition at a time. You'll see the rank now resets to 1 whenever there's a new category that comes around. Again, folks, the reason why you see like this is because we have it ordered by category ID. You don't have to order by category ID. You can order by any other things. 1, 2, 3, 4, 5. You can say order by 5. And you will see all the 1s for each category. All the 2s for each category, because that's how you sort the results, right? Okay. And you can also reverse that order. So we want the cheapest one to be ranked number 1. So now all the number 1s are cheap products. Alright, so folks, let me know if this is a bit confusing, or this makes perfect sense, or this is awesome. Like, and one more thing I want to mention is this is ANSI. Okay, when we say it is ANSI, it means it's available in Oracle as well. Okay. You will see this in Oracle database just as well. Okay, so any questions so far, folks? So we can say rank over partition by, so we've seen all that stuff. Okay. Now other function, such as sum, let's start by running this. Okay. I know this looks confusing. So before we talk about framing, we're okay with how it's partitioned and how it's calculated. That's fine. Okay. Okay. All right, so let's take a look at this result set. Let's first understand what's going on here. Okay. I actually want to have a, so that's all the data there is. So because it's 3 years. Fair enough. Okay, so any category wouldn't be any different. All right, so here, let's only look at this for the time being. Okay. This is one partition. This is one partition. And this is another partition. Okay. Now, we're using a sum. So this value here is just 1357. It's actually summing up from the beginning of the partition to the current row. So I'm going to use green to represent the current row, and blue to represent the beginning of that partition. Now, when we are doing the sum, when we move to the next row, so let's say the green is the current row, we are doing the sum from the beginning of a frame. Now here I'm using the word frame instead of partition because the frame can be defined very flexibly. For this example, the frame begins at the beginning of the partition. So here the frame begins at the beginning of the partition. So it always goes back. So the third row is the sum over that. Okay, so where the function applies from beginning to the end is what we define as a frame. Okay. So let's look at how we specified the syntax. So sum is what we're trying to perform. We're trying to add all the values together. We have a partition by category, so whenever there's a new category, it's the beginning of a partition. The way we are going to sort the records within each partition is by order year. That's why they are always 06, 07, 08, 06, 07, 08, 06, 07, 08. All right, rows between. Now that's where we define the frames. Between unbounded preceding means go all the way back. There's no limit to how far you can go back. Okay, so the limit is formed simply by the partition. Okay, rows between, that frame is bound by the partition and the current row. Okay, so I'm going to add a comma, and this time I am going to add okay, so this is okay, I guess I'll okay, so I'm going to do a okay, so let's see if I can make sense out of this query here. Okay, guess that's not how it goes. Order date. Wait a minute. Why is it not? Why is year? Hey, wait a minute. Why is it not doing that? Okay, don't panic. I know this is going to work. Or I have other ways to make it work. Huh. Come on, I just need a quick month, year. It cannot be that hard, right? Or maybe it can. Huh, it just will not give me years. Fair enough. Okay. And as soon as I get this out of the way, I won't have to look at it anymore. Okay, it's a weird way to do it, but you get the idea. And I want order by 1. Okay, so what am I doing here, really? I want a monthly sales sheet. Okay, so here I'm going to create a report. Okay. wrong with you? Alright, so that's my CTE. The CTE is not important, okay? So I'm going to select order month. Notice my CTE already gave me the order month, right? I can do a sum. Okay. Which is not a problem. Running total is easy. Okay. I'm just going to do sum of monthly sales Now, this is how I'm going to sum over. Order by order month. Okay. Fantastic. Now, what's all these weekly things about? About to find out. From report. Remember, report is my CTE, right? So, bam. Oh no. It doesn't want me to do the order by in CTE, which is totally understandable. Okay. So obviously to put sum there. Okay, so this is now a complete running total. Okay, that is the first record. That is getting all of that. Okay, and that will give you that much. So let's keep on doing the running total. Okay, that's not too crazy, right? That's pretty straightforward. But what about if we want something more? By the way, folks, keep your eyes on this query. Okay, the CTE is not important. So don't worry about the CTE at all, because right now we're trying to work on this something, because I want to show you how the windowing works. Okay. So partition by substring of order month I always forget partition happens before the order by. So partition by the first four letters. Oh. Okay, so it doesn't like that. No worries, I'll fix that right away. It was an integer before. That should take care of that. Okay. Now what you should see is that it's now partitioned based on the first four characters. So 2006, it's doing the running total. 2007, it's doing the running total. So for running total, that's perfectly fine, right? So we have a running total. So that's a running total at the end of 2007. Okay. So you can also call that year-to-date sale. Year to month. Cool. How about a running average? A running average between the month prior and the month after. So in other words, I want a new record here that would tell me the average. So I want this value here to be the average of these three values, and I want this guy here to be the average of that three values. That's when we need window. Okay, so this is how we can do it. This time we're going to use an average of monthly sales. And we're going to do so over the same exact criteria. But we're going to add additional criteria, rows, okay, between. So here we're going to say rows between 1 preceding. I can never spell preceding right because I always spell it with 2 E, and I know it, and I refuse to memorize it, and I just copy it. And 1 following. Okay, so here the frame is an average between one row prior to the current row and one row following the current row. Whoa, this is heavy, man. Look at this. And that actually works, I think. No? So that is now running average between. So if you look at this cell, you can obtain the average by using these three, because we are doing an average between 1 before the current row, that's that guy, and 1 after. So it's, well, you can do that, or you can say I want the between 2 preceding and current row. Okay, so we can say from between 2 preceding and current row. So what happened is, now it's a 3-month running average. So if that's the current row, it's 3 values, and because there's no 2 prior values, it's just that. Okay, and for the next row, it's trying to average the 3 things. Okay, and for this guy, it's the 2 preceding the current. So 1, 2, plus the current. So the average is now these 3. Okay, so folks, this syntax may look a little weird, but this is leaps and bounds easier than subqueries that we shown earlier today, and far more cool, right? Excellent. What? Why did that happen? So we're okay right there, 3-month moving average. Very cool. All right. Folks, any questions so far? Okay, so what else you can do with this? You can do quite a bit, right? You can also easily produce. Now I'm going to copy everything identical as the previous average, but I'm going to do something interesting. I'm going to do a sum. Hey, what's going on with this Chinese font thing? Why does it keep doing that? U2? It's contagious. Okay. Alright, so let's see what's going on here. Well, you really wouldn't want to do this because there's actually a lag function. So you really should use lag function for this. So let me show you how lag function works. Okay. Actually, I want to make sure I'm not going too crazy before I jump ahead of myself. So that's a sum, right? There's also lag and lead. I hope it's part of this. Good. Good. Alright, so since we do talk about this, so it makes sense if I just cover it. So I can say I want to look at the lag, and here I don't really need windowing function anymore. Okay. So let's see what does that give us? So here's my monthly sales. There's nothing. So remember, the column I'm producing is right here. Okay. So this guy has no one prior, so it's null. This row has one row prior. That's that guy. Okay. So that's lag 1, and partition by year. So when the new year rolls around, this guy has no prior values, which is okay. The beginning of the year is nothing to compare to before. So you can say lag of that as previous month and you can then use this to do a monthly increase or monthly decrease, right? Okay. And you can also include the lead. So rather than lagging, you can also say, tell me what's the next value. So you'll see that for this guy, now it's looking at the next value, which is this. And that is looking at that. Wow. This is some really powerful analytic functions, folks. And again, this is NC, meaning both Oracle support this as well as the SQL Server. Okay, so they both support this functionality out of the box. Alright folks, I'm gonna open this for a round of questions. I know, right? What a great time. It's all the way in the afternoons and I'm sufficiently confused. We'll talk about this topic in a nice sleepy voice. Alright, so Any questions, folks? Okay. Folks, are you okay doing there? Are you guys okay? Awesome. Yeah, and it's a good time to think about it because everything we've talked about so far is always dealing as set base. By introducing this sets of function, yes, there are obviously some newer keywords to overcome, but also it allows us to evaluate against result sets. Now, folks, that's definitely a lot of things to take in. Yeah, this analytics stuff is really awesome. Okay. Now, as you're working or as you're trying these demo code when you have time this evening, okay, just remember these are evaluated over partition, okay, and within each partition, how do we want to sort and calculate the results, and potentially provide the boundary of the calculation. All right, it is definitely a lot of things, a lot of stuff to take in. So to help you out, okay, let me throw this into the class notes. I'm just going to pile this out right on top. Okay, so this is SQL analytic functions. In fact, I like to call it analytic functions. I kind of don't like the window function because that sounds like Microsoft product somehow. Okay, but in Oracle you have the same exact thing. It's called analytic functions. Yeah. So you may copy this and paste into your SQL SSMS and try it out and see if you can make some adjustment, etc., and see if it makes sense. That'll be next month, actually. All right, so folks, again, looking at this, you'll be taking a while to absorb this. So, folks, have a good evening, or at least try to have a good evening. Think about this, and when we go over this topic again tomorrow, it will make more sense. All right. Now that's SQL windowing in a nutshell. Very cool. And you have the rank, the sum, dense rank, roll number, league led. Okay, first value of the partition. So if you want to compute the differences, for example, profit and loss, month to date. Okay, so you take today's balance and you minus the first of the month, then you can get all right, so pretty good stuff. So a lot of these functions will come to become very useful when you have to actually analyze the data. So folks, keep this in mind, and tomorrow we're going to give this a good